All right. Yeah, so my sister is pianoing, so we'll have that in the background. But that'll be kind of funny, I guess. Looks like, huh? Maybe that does cover up my face. It's a little inconvenient. Let me just. Uh, what do I even do about this watermark? Um, okay. Let's figure out how to move the watermark live on stream. Um, Surely it's in YouTube Studio. I would hope it's in YouTube Studio. Um, Community? That's not the right tab. Customization, surely. Ah, there we go. Okay. Okay, well, I guess that corner is just doomed. So, um, I'm just gonna move it to the. I'll just move it up a little. Call it a day. Uh, like, yeah. Surely that's fine. Um, it's still covered, but that's fine. I'll just deal with it. So yeah. Suppose I will start with leetcode. Okay. Miss me yet? No. Int number of ways. Oh, I got rid of Vim. Let me fix that. Settings. There we go. It didn't let me copy paste in Vim mode for some reason, which was a little annoying. But you know, that's how it goes. Number of ways. This is not a sentence. That's fine. Number of ways n can be expressed as da 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 da. Okay. Hard code every test case? That is a not bad idea. How's it going? Yeah, of course we have to mod it. Okay, sure. I think that's the correct number of zeros. I hope that's the correct number. 8. Okay, yeah. Hi, Janine. How's it going? Number of ways n can be expressed as da 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 da. I should probably read the problem properly. That would probably be helpful. Let me set the stopwatch so I can destroy my ego. So number of ways n. Sum of the x power of. What does this mean? Sum of the x power of unique positive integers. Oh, in other words, great. Number of sets of unique integers where. Oh, okay, sure. That seems like it makes sense. This problem seems a little annoying. And x. Okay, so x is the power. So okay. So I probably have to pre-compute things. That's probably not a bad place to start. Hmm. Oh no, this is a fucking DP problem. It looks like. Let's just look at this. Yeah, okay. Okay. Okay, great. It's like okay. Dad knocked on my door. Average average household experience. And my mom shared my channel link in the family group chat. Great. Wonderful. Okay. This lighting is also just doomed, I guess, but that's fine. Alright, what was I doing again? Oh, right. Brute force for no. Hmm. Can I even brute force this? What am I even doing here? What is uh I feel like I should know how to do this. So X is the power. N is like the number to okay, sure. This feels very much like 0-1 knapsack, which is a really big problem because I don't remember how to do 0-1 knapsack. 0-1 knapsack. Um, okay, well let's give it a shot. Vector. Uh, so number of ways to. Okay, sure. We'll figure it out on the fly. And equals. What do I default initialize this to? Uh, default size 1 and then vector of so I want each of these to wait. No, I'm over engineering this. So 0. Okay, yeah. This makes sense. I squared less than n. Is this right? Oh yeah, POW. Okay, this is not a thing. This is actually... Yeah. So, POW of I2 plus an n. Alright, what do I do from here? So if I... Okay, where am I? Okay. So the number, okay, yeah, okay, this makes sense now. So the number of ways at each I. No, this doesn't make sense. Some of unique positive integers. I'm popping a hint. So I was on the right track. Number ways to express k as the sum of the x power of the biggest number. Okay, sure. Oh, wait, this is gross then. Wait. So then this is size n0. Or I guess the default is to 0. Wait, no, this is 2D. Oh, that sucks. That really sucks. Well, we'll figure out how to pre-allocate things later. I'm gonna use the second hint. Numbers smaller than j. Which one's the power of x? That sounds... Okay. Try to use each one as the power of x to make our sum k. Oh, I see what's happening. Okay, sure. Um... Okay, so I need to iterate across. No, this is wrong. So on each up to n. I guess we could just pre-allocate this by like -1s. No, this is over-engineering it. Let's just do that for now. Yeah, quite struggling here. This is not going as smoothly as I expected it to. Yeah, I just don't really know what I'm doing here. I don't know what the solution to this is even remotely supposed to look like. So I'm kind of just building the plane as I fly it. Okay, here we go. This way we're making progress. DP, DP IJ equals not J. Wait, what? This K is the sum of the X targeting that is J. Oh wait, I see what's happening. Do I see what's happening? I think I see what's happening. Okay, yeah, I do see what's happening. Okay, this makes sense. I think DP of I minus j squared of j minus 1. J is that. This feels like it gets nowhere though. Wait, I should probably draw this out. Yeah, let's take that n equals 4, x equals 1. I'm just gonna do this on a little notepad. So, apologies, stream. Yeah, this is a pencil, I guess, sure. Let's just draw that array. And then it starts with 0, I guess. That's K. And then this is J. Oh, 0. Okay, so that's zeros. And then so that gives a, okay, I see. So this is the biggest number. Okay, yeah. So which ones do I need at 2? So to make 2, this should just not be possible. And then, so in this example, x is 1. Oh, so that's a 1. That's a, no, that's a 1. That's also a 1. And I should extend this out. 0, 1. Number is to make 3, such the largest of zeros. No, no. 2 is no, 3 is. 3, there is one way to make that. 2, there is one way to make that. And then this is impossible? Wait. Yeah, this is definitely impossible, yeah. Okay. Okay, and then the 4 column is interesting. So 0 is nonsensical. And then, especially the largest is 1, there's. Wait, what? 1, there's 0 ways. 2, there is 0 ways. 3, there is 1 way. Oh, we add the one below it. Okay, I see. Okay, this makes sense now. So then there's actually one way here as well. Okay. I think I understand it now. I understand it now. Okay. So dp at ij equals dp of I. Okay. Let's pre-allocate this then. This is -1. We can 0 this actually. Factor int size n. This is size n 0. Okay. Okay, so the 0 is always going to be nonsense. So we can skip that. dp of I j minus 1 plus. So that's the ones up to this point, and then we need to see if it's possible to add the current number. So if it's possible, then you add 1 to the number of ways to get to the predecessor. Okay, so here it would be I j minus 1 plus oh, but then how do we get an initial value on here? Oh wait, I see. dp1 will always exist. dp1 there's always one way to make it. Yeah. Yeah, okay, that makes sense. So then plus dp of I minus pow of j2. And what is j here? Um, and this one is also j minus 1, actually? J minus 1? Wait, let's see here. Okay, let's go through this again. So that one's a 0. Start there. One's 1. So we take the previous, and then it wouldn't compute this to begin with, actually. Yeah, okay, I see. Let's just try it this way for now, see if this is gonna give us even a remotely correct answer. Yeah, because it shouldn't include the current. No, wait. Okay, wait. J less than n. We can optimize this later. Let's do this the lazy way for now. So ij is ij minus 1. I don't know. Space that there. So if this fits in the size, so if j squared is less than I, yeah, okay, less than equal I. So then dpij, we add dp at I minus pow j2. What else do we add? So that, and then it's the largest number that I can use. I guess not the current number, so it'd be j minus 1 as well. Let's add the modulo here. Mod. We return we need n plus 1 actually. Let's give this a shot. This is probably wrong somewhere. That is not the way I wanted it to be wrong at all. That is also not how I wanted it to be wrong. Okay. Let's make this longs actually. Int cast. I don't think that's the problem, but I think I needed to do that anyway. Let's print. Whoops. Heap overflow? Huh? Oh, come on. +1. Okay, so I sized the thing in the wrong place. That's really awkward. That's not the number I wanted it to print. Does something already exist for this, or do I just need to like do this by hand? I need to do it by hand. Okay, great. +1 n +1 I plus. just gonna do this lazily. So that's not what's supposed to happen. Okay, so we have real numbers now, but I know what this one's supposed to look like, and this does not look how I want it to look. Do I need to add DP at 0, 0? Is that what I'm missing? That number's definitely not right either. So this should look like 0, 0, 0, 0, 0, 1, 1, 1. One? Is that how the numbers work? And then 0, 0, 0, and then 1, 2. Okay. Okay, so now I know what this is supposed to look like, I think. And this does not look how it's supposed to look. Oh, wait. Okay, wait. So, wait. Wait, okay. So this equals that. Wait, no, it should also be just ones, yeah. It should be ones across. Looks like. I've been on this problem for like half an hour now. This is great. 1 1 1 1 1 0 1 1 1. Okay, sure. So then okay, so this one has to be a thing, and then if I minus how of J2 is still greater than or equal 0. So then This is literally what I have. Plus equals. No, wait. Let's not worry about. Okay, yeah, we'll keep the mod because it doesn't hurt. So then, how do we get this number? So where does this 1 come from? It comes from. So the number of ways that we can make. Let's just run it and see what happens. I don't think I've made any changes to this. Okay, so that's not what I was expecting. I think I'm messing up here. Okay, well, it's doing what I want it to now. I think this is what I want it to do. I'm not sure. Oh, got something correct. That's good. That's progress. Might have accidentally gotten it correct, but this is not supposed to happen though. I'm comparing it against my sticky note, and it is not correct. I don't know where to put my sticky note. I'm gonna put it there. There's something wrong with this little bit. So you subtract this. So the way to make a number there with it should be with j minus 1. Okay, so 1, 2. Clink, yeah, same. I don't particularly know what I'm doing here anymore. So we have, okay, wait. What's going wrong here? This doesn't make sense. This stood out is confusing me. Why is it just quitting at 2? Yeah, so there's one way to make 1. It's figuring that out. It's not figuring out that there is a way to make 2, though. If power... Oh, I see. Whoops. Wait, no, wait, we're so close. We're so close. It's not square, it's to the power of x. Guys. Guys. Okay, let's submit this. Okay, well, it runs really slowly, which is not good. Why does it run slowly? That's not ideal. Why is it so slow? Oh yeah, I guess there's a lot of... Hmm. Alright, let's see the editorial. Let's see what I'm doing wrong. This meme is so real. Oh. Wait, what? Why was it optimizing space? Anyway. I guess I know why, but... Okay, so I had like the right idea. Why was I doing this? Did I accidentally get that correct? No, okay, that's still like piss slow. What's the difference? Oh, the loops are inverted, huh? Hmm. Wait, but that matters though, right? What if I... Oh, JX. Let's see if this even runs still. If this is way faster, I'm gonna be a little bit annoyed. Okay, that's expected. Oh, that's not the right button. Okay. What does editorial do? It's a long. No. Can... This should fit still. Okay, so it's still, like, piss slow. Why is it so slow? What happens if I actually just like interchange the loops? Nothing changes. Why is this so slow? So this extra layer? No, it's definitely not that. Yeah, this isn't making sense to me. I'm too dumb for this so far. What's happening? What's happening in this editorial solution? Oh, I see. Okay, so this is a little bit. Okay, wait. I'm gonna try it. I'm gonna try it this way. Let's also change this. Let's just hide that for now. So let's try again. Vector of long. Uh, let's do this. Oh, I see. Okay. It's greater than equals 0, I minus minus. That's not the right bracket. Okay. What's even happening here? So, okay, they duped me with this. So let each number they get a power. And if it's bigger than n, then it doesn't fit. Okay. So we're just like layering over it. Okay. So this is okay. So then if okay, that part makes sense to me. And then that's just getting the current power. And then all the numbers down. Oh, okay. Then n. Okay, this makes sense. Equals. So we get dp at j minus val. Yeah. And plus the current. And then we mod it all. That makes sense. Then after all that, we return to end. So is this faster? There's no way, right? Okay, well, I guess it is faster then. But why? I guess less allocation? Is that what's happening? I don't know. I'm quite confused, but sure. Sure. I guess that kind of makes sense. So anyways, what's I gonna work on again? Oh, right. I was building this out more. All right, so this is the middle IR so far. How long have I spent on that one LeetCode problem? An hour. Jeez. Okay. Great. Okay. Yeah. Okay. So I'd actually do work that I want to do. So we're designing an IR. I'm missing a lot of features still that would be quite important to have. But yeah, it'll do. What am I gonna add to this? Let's look at my prof slides. So what are the terminators? I guess I need branch statements still. I probably need those further up before I can really do anything other than just like single basic block return functions. So I guess we can be a little bit boring with this. Let's start translating instructions over. This is pretty one-to-one in theory. So declaration. So these three exist right now, is what it looks like. And then return exists. Return and then call exist. We have type var or s or var t op t. Oh wait, okay, this makes sense. That seems like a pretty reasonable set. And then terminators is just return type or return type variable. That's not the one. Okay. Let's get this done at least. This will be pretty straightforward, I think. Terminator. So let's steal this. Wait, this is not virtual because this exists. This is a real thing. So void accept and then terminator return. I guess exists. Do I declare all these here? Where is my mouse? There it is. I guess it doesn't hurt to leave. I'll probably need to implement this at some point, so I'll just leave it here for now. Then so I need to make this eventually assign value. And then I need binary op. Then just these three done, and then I need calls for now. Actually, let's do this the lazy way. Okay. So that's the current extent of my language right now, which is really funny because it is quite terrible. It's quite terribly small. I should implement more things, but you know, as it goes. What else do I? Set the private fields for everything. I think the structure is a little bit different, right? No, actually, no, it's not. It seems quite normal here. Right. Yeah. Okay. Seems quite plain and dry. This has a type. Is there a reason this just had straight declarations? I guess LVM does have that as well. So we're gonna do uh, it also just occurred to me that I would need to separate out types from this. So let's do that first. What do I have it as in here? Type singular. Let's make those a thing. Let's copy over the standard boilerplate. You can even just copy it over from front end, honestly. Where does it live? Utils. That's where it lives. Let's change these, the way these are written. Let's see what does LVM say they are. Let's just what's the flag again? Dash S? No. Emit LVM. There we go. What's this called? Oh, is it literally just unsigned int? Okay. Pick some other number. Interesting. So then How does the IR differ? Why did I wait? That didn't make sense. Yeah. So what happens if I do this? Oh, okay. I see. So it literally just converts them, is what I'm seeing, is what happens. Then we're gonna printf. Okay. Wait, so this is like a... This is just like a very basic question, I guess. Also, don't question the code I was writing here. So if I have unsigned and I equal... Wait. Let's make test again. Print signed at signed equals -1 sign that number. Let's make unsigned. Yeah, let's just let Copilot do everything. Let's see what happened here. Interesting. It's quite boring, as a matter of fact. It seems like a very boring way to go about this. Okay, so it just gets eaten, and then unsigned is just the... Okay. Wait. So then what happens if I... Let's just... Wait, what? Okay, sure. I don't know what that error was. Let's make this like -50. Yeah, let's let Copilot do the work for me. Okay, so it makes literally no difference, which I guess in hindsight I probably should have known. Um, yeah, because it's literally just data. I feel a little bit silly for not realizing that numbers just work like numbers. Um, sure. Okay, great. So now we can just let's just yeah, let's just yeah, let's just do this and call it a day. Um, we can be kind of minimal with this. This is a little bit silly, but you know, the sacrifices we make. Middle end utils. Or no, mir type. Let's just steal all this. And then that's not 64. Yeah, it looks good to me. Okay. What were we working on again? Ah, right. Yeah. So let's get rid of this and then wait. Why is this front end? Yeah, we just have a random floating diagnostic. That's great. Uh, okay, we just have all the floating diagnostics. That's great. You know what? Oh, and it moves with. Love to see it. Okay, so what's going wrong here? Did I spell? I spelled middle end wrong. There we go. Then in mir we can import that. Aha. And then let's actually import that here as well because I kind of need to. That's not how I import it. Add mir proper. Oh, that's not what I want to do. sure. Okay, what changes do I want to add again? That is a okay, yeah. Mir.h. On this one we place do that, and then now I can actually do what I wanted to here. Private fields. So we have a type, and then the variable needs a name. It needs a name. So let's add. I don't actually want to use like I don't want to use strings because they're annoying. So I'm going to use something even more annoying, which is numbers. I'm just going to make... Is that how I did it in the front end stuff? Declaration has... Yeah, it's called variable. So yeah, variables, I'm just not going to give them names anymore because names are annoying. And variables are supposed to change a lot. Yeah. Or I guess more specifically, it doesn't map one-to-one. So that's what LLVM does, it looks like. I could be wrong. Please correct me if I'm wrong. Okay. This is where I need to think about how values are encoded. How I wanna if I want to do encoding here. I probably should do encoding. Yeah. I could just have a separate bit altogether, but encoding is like the technically correct thing I should do, I think. Okay, let's get the obvious stuff out of the way. I need a variable to apply it to, and then do I encode this? The correct thing to do would be to encode it. Let's look this up. Oh, this is not helpful at all. Okay, well, great. We're just gonna is value. We're just gonna do this for now, and if a problem comes up, I'll fix it. So then this is value. Ugh. Where am I? Okay, value, and then bool is literal, I guess. Value is literal. a little bit of gross stuff never hurt anyone. And then, okay, I understand why this is a little bit gross now, actually. So we're gonna left, right. How do I, what bind is that? That's, is it Q? I don't want to try it. I don't particularly care. Yeah, that's a little gross, actually. You'd expect there to be a better way to do this, and there absolutely is a better way to do this, but I've been quite lazy, so I don't know what the better... I guess I could wrap it in a class, but then that's more bloat. I guess this is literally like the whole atom situation, huh? It never... I can never escape it. We're just gonna keep this as is for now, and then add a to-do for myself. I need to add the boilerplate to all of these. Actually, what if I didn't add the boilerplate right now? That seems simple enough. Is a call a terminator? I don't think it is, right? Terminator? No, it's not. Oh, I see. A terminator matters insofar as basic logic, not in terms of actual function boundaries. So it just occurred to me I've not been calling this anywhere else. I've not been calling it callee. I've been calling it target. That's gross. Let's add a callee there. And here we have just adding a variable. We can save a little bit of bloat, I think, this way. And then here we can private. Value, and then value is literal. Okay, yeah. Okay. I should push that. And then real quick before I like get even more upset at myself, target. Are these all target? Okay. Let's callee. All callee? These are all callee. 2, 3, 4, 5, 6. Oh, I see. Yeah. And then that doesn't exist here. Okay. All right, that change is made. I should probably make this real quick. Just make sure it works. That's not the right directory. Okay. That looks correctish, I guess. Okay. I think that's like all of the reasonable changes I plan on making for now. Yeah, I think the code gen is not particularly interesting right now. Um, just because I don't have branching structures at all. It's just straight line code, so we just have functions that are a single basic block. But you know, as it goes. Um, yeah. What else am I really? What else do I want to work on right now? Oh wait, I need the operator. That's what I need. Um, let's go back down a layer. Where does this go? This is the wrong directory. How do I do operators here? Put them in utils? Yeah. Yuck. 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 Does Godbolt support all these? Uh, so addition definitely exists, and then let's just make all these different times, and then did I do and? Always and? So it's just pre-computing everything. I guess that's kind of expected, but like still, that's kind of annoying. That's not the right page. Okay. I just tried to run this like a leetcode problem. I'm so cooked. It's just folding it down, huh? Okay, we're gonna have to get a little bit more. There we go. That's a mold and okay, yeah, so they all exist. I guess I'm a little bit silly for not realizing that they do just factually all exist. Um, yeah. So then, what else do I need to do? Add sub mole and operator like Palantir. I hope I'm spelling those correctly. That would be bad if I didn't. I guess these don't change at all. Add sub mole and then end. On MIR, let's add operator. Are these binary op? I guess binary op, sure. Yeah, okay. This is the correct term. That's that's gonna go in like a that's gonna go into one of those like Minecraft field crafting compilations. What else do I add? I should probably add the operator to the instructions that need it. So we have binary op. Let's add that there. T. O goes before T, yeah. We have binary op. And then I should modify CMake lists. That's what I'm forgetting to do. Huh? Oh, right. Middle end MIR. .cpp. This one's instruction. Operator. And then this one's type. Should probably alphabetize these. Unless I have a reason to not. Uh-oh. Where am I getting this wrong? Why are these not? That's not ideal. Yeah, that's a very awkward mistake to make. Just make sure all of these headers are correct. This better make. Okay, I think that's passable progress for one day. Yeah, it's top of the hour, so I think this makes sense as a good time to call the stream. Yeah, casually spent a whole hour doing a leetcode problem and then only half figuring out what was happening, but you know, as it goes. So yeah. Yep. All right. Take care, chat.